Hey guys, Professor Doney back. We are in the middle of circuits, and today we're talking about Kirchoff's rules for complicated circuits. Now, when we say a complicated circuit here, what we're really saying, at least in this situation, there's greater than one voltage source. Okay? In our situation, we have a 50 here, and we have a 60. Now, if those two were next to each other, if those voltage sources were in series, we could deal with them, combine them, them being in series, or if they are in parallel by themselves, we could look at that option. But here they are actually in separate loops, so they're not next to each other. There's some things happening between them, so we would say there's greater than one voltage source. Now, Kirchoff's rules have two. He has a loop rule, and he has a junction rule. Now, the loop rule says that if you start at some point, let's call this little point A, and I go all the way around from A back to A, so I go around the entire loop, whichever loop I pick, this left one or the big outer one, that the change in voltage will equal 0. So if I have 50 volts right here and I have 50 volts right there because it's just a wire, and I go all the way around, I lose voltage and go back through the battery, I should still come back and have 50 volts. Okay? The second one is a junction rule. It says anytime I come to a junction, like here at B, I come to a junction at B, if the currents are going in, say I1 is going in and I2 are going in, I3 goes out, I would write a junction rule that I1 plus I2 has to equal I3. Sort of a conservation of energy idea, that the currents in equal the currents out at any of those. Alright, so how do we solve these? Well, we're going to go around, make sure everything is labeled plus minus. I'm also going to put here in between all these different devices, I'm going to label some points so I can sort of keep track of where I'm going, and I'll call that F. A, B, C, D, E, F, we go across. That way there's a label, lowercase letter label for in between all devices. Alright, so how do I do this? Well, we're going to start out by looking at the junction rule. I'm going to start with that one first. And at junction B, I have to look at the currents. Now, I'm expecting the current to come out of the 50 this direction. Now, once it gets to here, it has to split or do something. So I'm going to say in this whole left loop is I1. Now, I'm going to say it comes in here. Since current is coming out of, I would expect coming out of the voltage source here, this direction, because that's the way the battery is pointing. It's pushing that way. I'll call that I2 over here, and that's going to be that entire loop. Now, those two coming in there, I can't have this current and this branch going in there too. I expect this to be coming out. So I'm going to say that's I3 going through that center piece. So what I have at B is I have I1 plus I2 equals I3. Now I could check down at E, and what I have is I3 goes into I1 plus I2. And that's the same thing as at B. So I look at those, what's coming in has to equal what's going out. And look at E, what's going in is I3, what's going out is 1 and 2. Alright, so that takes care of our junction rules down. Now our loop rule. How do we do the loop? A little differently, but the idea is the change in voltage has to be 0 all the way across, or all the way around. Let's get a better color here. All the way around. So I'm going to start at F, and what I need to do is I walk around there, I have to see the voltage go up or change. Okay? I have to see. So I'm going to go from, well actually, yeah, let's start at F. Alright, we're going to go from F, we're going to go to A, then we're going to go to B, then I'm going to come down to E, and then I go back to F. So I'm looking at this left loop right here, L, L. Now I'm going to run out of time here in a few moments, but what I'll do is make a part 2 and 3 if I need it for this video, just to continue what we're doing here. Alright, so what I do, I start at F. What voltage do I have? I have 0. And then as I go through the battery, since I'm going from the negative to the positive, I'm adding 50 volts, so that's going to be plus 50. And I go from B, now I'm going in the direction of current, so I'm going to have a voltage drop right there.